In this video, we're going to be talking about hybrid models, which is one of the models for explainable and responsible AI. This is a subset. Hybrid models are a subset of explainable and responsible AI. And these models, especially those focusing on neural-symbolic integration and ensemble techniques, represent a synthesis of different AI methodologies to achieve high performance and interoperability. And here are the different methodologies that are synthesized. The development of these hybrid models in AI, especially the ones focusing on the neural-symbolic integration and ensemble learning techniques, they help us visualize the concepts in a form of very much of a diagram like this that you can read. And neuro-symbolic integration is basically a depiction of combining deep learning with symbolic reasoning. That's the starting point. When the second step is the neuro symbolic systems in complex tasks that show that there's like a synergy between the strengths and the interpretive reasoning. And the third is the robotics, for example. That's mostly neuro-symbolic systems in processing sensors and data and decision making. And in terms of the ensemble techniques, the ones that I have selected here, the 3 ensemble techniques, it's basically a combination of, so advanced ensemble methods would be a combination of decision trees, neural networks, linear models. And this is just an emphasize that there's a balance of accuracy and interoperability. So the more you try to integrate, maybe the accuracy is going to be lower. And that's why we need to also use model agnostics interpretations like Sharp and Lime, and not only rely on ensemble techniques. But there's also a feature here in domain-specific applications where ensemble techniques add value. So specifically in healthcare or finance, ensemble techniques can integrate different types of models for improved outcomes and improved interoperability. But let's look at this in more detail. Let me change the cover of the pen, and let's start with the neuro-symbolic integration. This category combines research on, as we said, deep learning and symbolic reasoning. And then this domain is trying to integrate the learning capabilities of the neural network with the interoperability and logical reasoning of a symbolic AI. And this integration is very challenging because of the fundamentally different nature of these two paradigms. So the neural networks are known for their ability to learn from vast amounts of data, and symbolic AI is known for its rule-based logical processing. That is the difficulty over there. But moving on to the second one, the neurosymbolic systems for complex tasks. This is when you create neurosymbolic systems capable of tasks like visual question answering and natural language understanding. These systems combine the perceptual strengths of neural networks with the interpretive and reasoning abilities of symbolic systems, allowing for complex tasks that require both understanding and sensory inputs and performing logical reasoning. And moving to the third category of interoperable AI in robotics and automation, projects that apply neurosymbolic systems in robotics and automation usually use sensory data like vision and touch, and these symbolic systems provide the framework for decision making and reasoning, and this enables robots to perform complex tasks while offering explainable decision processes. Now moving to the next category, and let's change the pen again, moving to the ensemble techniques. Starting with the advanced ensemble methods for improved accuracy and interoperability, research in this area involves developing sophisticated ensemble techniques that combine various models such as decision trees, neural networks, and linear models. The aim is to leverage the strengths of each model, the accuracy of complex models like neural networks, and the interoperability of simpler models like decision trees. That's the objective in those. Moving on to the next one, feature importance and interpretation. In these projects, often we employ model-agnostic interpretation techniques like SHARP and LIME to understand the ensemble model decision. And these techniques are used to derive feature importance metrics from ensembled predictions, providing insights into how different models in the ensemble contribute to the final decision. And in terms of domain-specific ensemble applications, there are significant efforts in significant attempts to apply ensemble techniques in specific domains like healthcare and finance and environmental modeling as well. For example, in healthcare, ensembles might combine image-based diagnostic models with patient history-based models to improve diagnostic accuracy while providing interoperable insights into the decision-making process. And in summary, these hybrid models represent a very promising direction in AI research, including the impact from performance and reliability. Often the neural-symbolic integration is very notable for its potential to create AI systems that can both learn from data and reason in a human-like manner. And ensemble techniques, on the other hand, they leverage the diversity of multiple models to enhance performance and reliability. And they also offer avenues for interpretation. The advancement in these areas would be crucial for developing AI systems that are effective, efficient, but also transparent and accountable. Now, I think this is enough. Let's move on to a different topic.